Good morning, everyone, and thank you, Vincent. I'm going to talk about the digital solutions. So, how we build digital solution to monitor the plastics, like bringing digital tools, geospatial tool to tackle these monitoring challenges. And then I agree to present the work we completed under the UNEP countermeasure project from 2019 to 2022. And that time, actually, I've been in Asian Institute of Technology, AIT, but I was affiliated with the Geoinformatics Center. So, and my specialty is the geoinformatics. So we try to bring geoinformatics into different domains and try to solve the problems in the environment. And in this case, actually, when we started to work with the countermeasure project, so we took one component, like how to utilize geospatial technologies. Actually, it was in the countermeasure phase 1. So when we talk about, like, we bring digital, geospatial technologies. And when we completed countermeasure 1, we realized that we have collected so much of data through the cities along the Mekong River. And then we started to, when the UNEP was conceptualizing the phase 2, then we come forward and say that, okay, we can bring some insight. So let's think about digital tools, like how we can build top of the data we collected, and could be also potential to collect in the phase 2 and try to make it meaningful. And this was actually, building these tools is like, it's not that we had a TOR in the beginning, we do like that, but we went like eventually the phase by phase. I would say it's like the COVID gave us a really boost for us to be more innovative, to do this kind of thing remotely, which bring at the end of the project, which bring for people to think about to do by themselves. And I think this project was submitted to the recent SDG summit in US. There was a competition to select what are the influential digital tools in the global level. This been submitted by UNEP. And then there was around 300 applications, and this project was selected under SDG 14 to present in the SDG summit. And I would acknowledge it's not only my work, but there's a big team and partners in the project throughout work, like 2019 to 22. And let me quickly, because of the time limitation, I will quickly jump into, so anyway, I will bring one of the captures, like this is I captured by myself. The location is Chiang Rai, but it's not only responsibility of Thailand, but it's responsibility of all the colleagues upstream. You can see that this location in Chan Sen port, you can see the garbage bags and many things. There's a port, but there's an obstacle. These things are accumulating in short span of the across the river. And also this is in 2021 November, we opened one bag actually, took it out. You can see that all the COVID related things being dumped into the Mekong River, and it floating the garbage bag. Let me quickly jump into the solution that we thought about in different phases. When you come to think about the digital solution, we have to think about data collection, and then building the algorithm to analyze those data, and then how to represent these data sets. In this case, we've taken like 4 approaches. The road network, how we can build plastic litter map across the city. Can we do that? Like, can we make benchmark plastic litter map for cities? Second one is, like, can we fix the CCTV camera and then across the canals, and how we can do the monitoring, how we can use the drone. And also, many people is using mobile apps, so how you can utilize this kind of platform. And as I mentioned, so when we are working on the city scale map, so what we did because of the COVID restriction, we packaged the camera and all the instruction and post it to our Ubon Ratchathani colleagues and also Chiang Rai. And then we gave them instruction where to travel, fixing this camera along the city. And then we take the data back, they upload the data back, and then we start to build the machine learning algorithm and then try to produce the identification of litters along the street. And if you see here, so this is the very, very initial video that we produced, like it's not very clear. You can see that along the street, the items plastic litters are detecting while it's driving. And based on that, if you focus on the right-hand side, here you can see that we try to produce two benchmark litter maps. Like one is in 2021 October and 22 January. What it reflects across the city, this is Ubon Ratchathani, how it looks like after detecting. Because as I mentioned, this was built like very agile nature. So we went step by step, which are the possible things over the time. Yeah. And this all work is being packaged. If you visit to the plitter.org, plitter.org, you can see all the tools are being packaged. And then, like in the street level, you can see that, like we tested several cities as in the slide, and then you can see the really evidence how the detection. So in this case, like what we felt is like if you say this is the plastic litter, we want people to see what has been detected. So it has been packaged this way. You can click onto the street and you can see the video that we captured and what has been detected and what is the heat map we produce. And I think this is a very important part. I think everybody knows. And even nowadays, you have seen many AI algorithms. We're very familiar with, like detection of faces, detection of vehicles. It's very straightforward, I would say. But when it's come to the plastic, you can think about one item, like let's say bottle. It can have different ways of, like it can be dirty plastic bottle, scratch plastic bottle, many ways, same item. It's quite complicated when you think about detection of these things using AI algorithm. So what we have to do is, in this case, we start to think how we can overcome. And we had this project-based task, like we had several cities, Ubon Ratchathani, Kanto in Vietnam, and then Cambodia and Laos. And then what we start to think about how we can use citizen science approach, how we can bring this kind of a diverse nature. And we captured the data. What we did is we did a small platform, and then we did the detections, and then we use university students in different countries, and then we organize online workshops, and they check our algorithms, and then they check the prediction. They help us on correcting the mistakes. So we went through we call it active learn concept. So we see the mistakes and then improve the algorithm and went to that next level. So our target was to build a kind of a robust model at the end. And what we have done so far, you can access through if you're familiar with little bit programming, you can go to the GitHub repository and you can go to the plitter page. You can download all the algorithms up to date. It's open and free of charge. And there are two things here. One is the algorithm, one is the data set that we develop. The developing data set is the most challenging task because you have to collect and you have to, we call annotate, categorize, and then that data set is being also published. And here what our intention is, like we want people to take over these tools and you can customize your tools the way you want. It's only thing is like if you connect and another reason I wanted to present this one is here we have the government official from the countries. So you can think of these are the tools that are available. And only thing is like if you think about really good partnership, like you can reach to your local university, computer science department. They can bring this one in very easy way. And if you see this right-hand side, even if you online, you can drop the video you captured and you can see the detection itself. It's very easy to automate it the way we build these tool sets. And also we started to experiment different approach of data collection. We had several ideas like, can we use the Grab motorcycle to collect data? And colleagues was talking about the municipality trucks. And then we packaged this tool into a small box and we tested in the municipality truck. It's scalable. And also now the algorithm, you can do the real-time prediction as well. And in the things we face in our project, because we save all the incoming data in our database and it was very huge. And then we start to think about we call edge prediction. So you detect detect the litter and then you keep only the inside, but you delete the raw data because it can overcome majority of these backend problems. So these are the platforms that we tested. And let me check my time. Yeah. And other part is when we talk about the CCTV, so I think this is a little bit not really the CCTV that you may think about when I told you. And here what we wanted to do is we wanted to build a kind of a CCTV tool that low cost, which can be replicated easily by stakeholders and keep the cost low as possible. So we initiated this CCTV tool in Chansen Port in Chiang Rai. And we started with the AC powered and then moved into solar powered. We tested near the Taklon municipality. And the team is now working and they have now new versions. It's all compact and very small type of CCTV. And because of this product, there was the team is engaging with a European project called Inspire on implementing this CCTV in Italy along the one cross river. And you can see that this is the detection. Actually, even myself, I didn't believe my team that they could do this part actually. Because when I mentioned that this is little different project, it's not like writing a manuscript at the end, but we wanted to have a real practical detections. And then we were able to detect this all plastic, even the floating plastic. It is very complicated. When you see the object, some part is submerged, some part is surface, and you can test yourself. And this has been open source, people can utilize. And this is the pliter.org page. If you go to CCTV, and you can see the time series, even you can see the inside, what has been detected. And in the next phase, the team has been implemented 12 CCTV in the Kanto. So in this case, we did the kind of a remote consultation for Kanto team, teaching them how to build it, and they build by themselves. They build actually better than us, I would say. Like that is the replicated model that we tested in this digital tool. And how many time I have?
You're good.
Okay. And so in this project actually, as usual, we started from the mobile app. And in 2019, we had a focus of monitoring 3 aspects: artificial barriers, littering hotspot, and uncontrolled dump site. And here, we didn't use the crowdsource method. We had partners, you can see here, Mefaluan and all universities. And then we built the guided questions, and then to understand the situation in the ground. And with the consultation of the waste expert from UNEP and other partners. And what I want to bring it here is the platform was built in 2019. You can see the countermeasure CM project phase 1. And then when we moved to phase 2, we were able to really capture very representative 4,000 points through the partners. And then when people start to see that now this was tool being used by other projects as well. So this is what we interested is when we, people like us, we take a project from funding agency, could be ADB, World Bank. We do the project and after that, no more use of this kind of tools. That the time we spend and also the financial resources being spent, being underutilized. So this is something we wanted to highlight, this kind of platform, you can keep it. And you can see this one, this analytics part you can build very easy. Nowadays, these tools are very easy as well. And if I touch upon a little bit, so my last 2 slides. And what I try to say is actually, if I highlight one more thing with Professor Vishu, I think Professor Vishu actually reached to our group and he wanted to see that how this tool can be localized, how local governments can adopt. He is now looking into our tool that what are the necessary things that when it comes to the capacity building, what are the things need to be done. So he's doing this assessment and we are really also fortunate. So because our expert is to build something, but the experts like you, if it is a good case, you can take over to the next level. So that is and then as our responsibility, we keep it open source. And here what I want to say is I think this kind of you can implement CCTVs, you can think of how you can, if you install into different canals, you can have the different inside, how these canals in the cities been performing well. And you can increase the awareness for the community. Say your canal is like this, but you see the other neighborhood, their canal is very clean. So this is something that you can think of, we can think of it's very simple thing, but you can do the good awareness with evidence-based kind of thing. And one more thing, I just wanted to highlight one product we thought of, because we were capturing every 15-second data in Chiang Rai. then we had a huge data set. And you cannot bring analytics to tell the story. Then what our team was come up with this idea, like, okay, let's try to see 1 week in 1 minute. And then you can go to this playlist. You can see more than over a year, you can see the same point. Like 1 month, you can see in 4 minutes. And when you start to see, you can see this is the Mekong River, the big barrels, even the sofas, even the mattress is coming over floating, which is, for me, is like, I'm not an expert, but sometimes plastic bottle is acceptable, but when I see other objects, it's really unacceptable objects being thrown to Mekong River. And in similar way, so this is the same thing I explained, like we can think of benchmark heat map for cities. Like every year, you can utilize the municipality truck to collect data and build the heat map for this year. Like if it is a mayor want to go for the next election, everybody talk about the political willness. Everyone complain about political willness. But how expert like us can help politicians to have their agenda. So we can tell to the politician, hey, use this kind of tools. You can have your campaign next year, but you have to be committed to keep the city clean, and then you can have the evidence-based political campaign. Yeah, thank you very much.